So in today's session, we are going to see the layout of thermal power plant, coal and ash handling systems. So regarding this layout of thermal power plant, so the diagram shows the arrangement of various equipments which are being used in the thermal power plants, and also it shows the flow diagrams, the working fluids flows to the various equipments, and finally the power is produced. So considering this thermal power plant layout here, so this is the prominent device, the boiler. This boiler gets coal and air for the combustion. So that will be supplied to the combustion chamber here. So generally the coal will be stored in the coal storage yard, and the coal will be processed and it will be supplied to the combustion chamber in the powdered form through the conveyors. And for the combustion of this coal, so air will be taken through forced draft fan and it will be supplied here. And for the feed water supply, generally thermal power plant needs huge amount of water. For that we need to have uh, water resources. Generally the water will be taken from a pond and that will be supplied to the feed water processing plant. In the feed water processing plant, the scales or impurities in the water will be removed. So it's very important, we need to remove the uh, scales present in the water. Otherwise, during the formation of steam, the scale will deposit over the tubes, the various heat transfer devices. The scales will act as a resistance for the heat transfer. So it will reduce the thermal efficiency. So it is very important to remove the scales from the water which is used in the boiler here. So it will be treated and the water free from scale will be supplied to the boiler for producing the steam. So in the boiler, as we have seen in the previous discussion, so we'll use high pressure boilers and the water will be supplied to the boiler, and when the hot gases after combustion, when it is flowing from combustion chamber to the various stages, starting from radiant evaporator, convective superheater and economizer, so the steam will be produced. Steam produced will be a superheated steam, will be at the elevated pressure and temperature. So that steam will be supplied to the turbine, steam turbines. So in the steam turbines, the superheated steam will be expanded. So it possesses very high enthalpy, so that heat energy is converted into mechanical energy when the steam turbines, when the steam is flowing through the steam turbines here. So the power output from the turbine will be used to drive the generator, and we produce electricity, and that will be coupled to the power transmission towers and subsequently to the grid. The steam after expansion coming out from the turbine will be supplied to the condenser. Generally the pressure of the steam will be very low at the outlet of the turbine here. So the condenser pressure will be always below atmospheric pressure. So that will be taking up the steam which is coming out from the turbine. Since the pressure and is very low and volume will be very high, so the specific volume of the steam will be very high. So we need to have a larger size of the condenser to accommodate such a high volume of steam here. the working fluid, which is in the vapor form, that is the steam, again has to be used in the boiler. But say since the steam volume is very high, so it is difficult to handle. So so it will be converted into a water, so that we can able to pump the working fluid again to the boiler. So for that, the steam has to be condensed. The steam entering into the condenser will be passing through a condenser. So condenser will be having large number of tubes of smaller in diameter. For that, we'll be using a cooling water. Cooling water will be taken from a water resource, and it will be supplied to the condenser. So the cooling water will be flowing through the tubes, and the steam will be flowing over the tubes. So the steam will be condensed. The condensate will be taken, and that will be again supplied to the boiler, and feed water will be supplemented. So again, the water will be used for producing the steam here. And the cooling water, which is coming out from the condenser, has to be cooled, so it will be supplied to the cooling tower. So we'll be having a large cooling tower in the thermal power plants. So by evaporation, the cooling water will be cooled again, it will be supplied to the condenser. So in this way, uh, so we can understand the layout of a thermal power plant, how uh, the coal and air will be supplied for the combustion, and the water is fed to the boiler for producing the steam, and how the steam will be used for expansion in the turbine, and the steam which is coming out from the turbine, how it is condensed, and again it will be converted into the water. So in this way we can understand the entire the workflow in the thermal power plants. Coming to the next one, coal and ash handling systems. So in the thermal power plant, generally we receive coal uh, from the mines. So it will be in the it will not be in the uniform size, and also it will be having a lot of impurities, since those coals are being taken from the mines. So it has to be properly processed, and we need to remove the impurities present in the coal, and also we need to make a coal in the uniform size for proper combustion of fuel, as well as so we'll powder the coal. We'll be using the coal in the pulverized form, so that the combustion efficiency will be higher. So for that, generally we'll be having a coal processing unit in the thermal power plant. There are two types of coal processing unit. So we call it as a unit system and a centralized system. So this diagram shows the unit system of coal handling unit. The coal stored in the raw coal bunker. So this is a storage yard. So that will be the coal will be taken from this raw coal bunker, that will be supplied to the feeder. This feeder uh, will be used to supply, otherwise deliver the coal to the pulverizing mill. This feeder will be having the provision of receiving uh, hot air or the flue gases from the boiler, so that we can remove the moisture from the coal. The presence of moisture in the coal will reduce the combustion efficiency. So we use these flue gases or preheated air for drying the coal, and the dried coal will be supplied to the pulverizing mill. The pulverizing mill will use this device to grind the coal in uniform sizes, and also in the powder form, so that will be supplied to the boiler through induced draft fan. So this induced draft fan will create vacuum and it will draw the huge amount of coal, and that will be supplied to the furnace of the boiler. So generally, if you see the furnace, so there will be provision for supplying secondary air. So here we'll have air plus coal will be supplied. So the secondary air is absolutely essential uh, for a complete combustion of coal. So this air is nothing but when we calculate a stoichiometric requirement, based on the stoichiometric requirement, this air will be supplied here, and we need to have excess air. This is a theoretical requirement of air. So we need to have some excess air for the complete combustion. For that, secondary air or excess air has to be supplied for completing the uh, combustion of this coal. So this unit system will be used for separately for each boiler unit. And when we see the centralized system, so this one will be having a coal handling or preparation unit, a centralized unit. From this, the coal will be supplied to the each unit separately. So for this, we'll have a raw coal bunker, is a temporary storage yard. From that, coal will be supplied to the feeder. So we'll supply hot air or flue gas to dry the coal and also to remove the moisture content. And then this dried coal will be supplied to the pulverizing mill. The coal in the powder form will be taken by the induced draft fan and it will be supplied to the cyclone separator. The cyclone separator, so the coal will be supplied. So we'll create a whirling motion here. So the heavy coal particles will be supplied to the bottom of the cyclone separator, and lighter coal particles again it will be taken, again it will be supplied to the mill, again it will be coming to the cyclone separator here. So heavy uh, coal particles will be supplied to the conveyor, and so that will be supplied to the central pulverized fuel bunker, from where this will be supplied, the pulverized coal will be supplied to the individual units. For that we'll be using a forced draft fan. So this system will be connected to the individual boiler unit, so that the centralized system ensures that the supply of coal to the individual boiler unit without any interruption. The next one, ash handling system. So when we burn the coal in the boiler, a huge amount of ash will be produced. So that has to be properly handled and that has to be properly disposed. For that, so there will be a separate ash handling unit or system will be used in the thermal power plants. The ash at the bottom of the boiler from the furnace, that will be taken and that will be supplied to the crusher. In the crusher, the ash will be converted into a, because we'll be having some solid ash, so that will be crushed and that will be converted into a powder form, and that will be connected to the a flow line. So where that flow line in turn connected to the exhaust fan. So it will create a huge force so that we can able to draw this crushed ash along with the air through the ash separators here. So when the ash is passing through this ash separator, in this ash separator, so, the ash along with the air will be supplied and it will be passing through the swirling motion here. So the heavier ash will be collected at the bottom through the ash hopper, and the fly or lighter ash which is above, again it will be going to the next stage. There uh, slightly heavier molecules, again it will be collected, and these lighter ash molecules will be supplied through the filter and it will be sent to the atmosphere through exhaust fan. The ash collected through to the ash hopper will be taken by the ash carrying truck and that will be disposed of. So in this way, the pneumatic ash handling system will be used to collect the ash from the boiler unit and it will be disposed of. Due to the formation of ash and when we handle the ash, uh, so there is a possibility of a larger amount of dust. So that has to be properly collected and again that has to be disposed of. For that, in thermal power plants, we'll be using various types of dust collection systems. So this one, a mechanical type dust collection system, we call it as gravitational separator. So in this diagram, the ash with the dust will be passed through a variable area passage. We'll be suddenly changing the cross section here. So there will be increase in area. So there will be a pressure drop. So the pressure drop causes heavier dust particles to collected at the bottom and that would be disposed of. This is another way which you are seeing in the diagram B. So when the ash is supplied with the dust and we'll suddenly change the cross section, we'll just change the flow direction here. So there will be pressure drop so that the ash with the dust will be collected here. In the case of a mechanical separator type, so we'll use baffles. So we'll just cause pressure drop in the flow so that the ash will be dust will be collected along with the ash that will be disposed of. This is a very simple type of mechanical type, a gravitational separator. And the next one, another type of dust collector, we call it as a cyclone dust collector. So in this cyclone dust collector, the ash with the dust will be passed through a conical shaped dust collector. And when it is passing through this dust collector, because of the centrifugal force, the heavier dust particles will be thrown and it will be collected at the bottom and the uh, light dust particles will be taken so that will be supplied through the filter and to into the atmosphere. The collected heavier dust particles will be taken and that would be disposed of. So in this way, uh, the dust will be collected from the ash produced from thermal power plants. So we'll use mechanical type dust collectors. That's all about layout of thermal power plants, and ash and coal handling systems, as well as the dust collecting system, which you have seen in the module 1.